Hi, everybody. Professor Monty here today, and let's talk about integration by substitution. Now, integration by substitution is going backwards. It's the integral equivalent to the chain rule. So what we're looking for is we're looking for an inside function where if I was taking the derivative, I'd have to apply the chain rule to say, oh, times the derivative of this inside function. So I'll give you a couple examples today. Here's one of them. Notice the inside function is pretty easy to determine. It's this x squared plus 3. So what I do is I let u equal x squared plus 3. Sometimes they call this u-substitution, well, because we usually use the letter u. But what I do is I take the derivative of them, just finding du. So du is 2x, but I have to put on the dx because it's a different variable. It's not u as the variable, it's x. So I say times dx. One way to look at that is you could do it in Leibniz notation, where you say, well, du dx is 2x. And then it's sort of like multiplying both sides by 2 dx to get here. But usually we just jump straight there. We're saying, okay, let's define what du is. Different variable, so I have to apply that dx. So what I'm looking for is I'm looking for a 2x dx, which I have right here. I'm going to replace that 2x dx with du. So this piece just becomes du. The x squared plus 3 becomes u to the 5th power. And now it's something I know how to integrate. I'm like, oh, that's easy. Remember, to integrate, you go up 1 in the exponent, multiply by the reciprocal, and then we'd have to plug in this plus c. Well, the answer is not in terms of u, it's in terms of x. So now I just resubstitute, and I take that x squared plus 3 and plug it in where the u is. So this becomes 1/6 x squared plus 3 to the 6th plus c, and I'm done. Remember, we can always check by taking the derivative. And think if I took the derivative, I'd keep the 1/6 constant multiple, but I'd bring down this 6 times the 1/6, it's going to cancel out. Times x squared plus 3 to the 5th. And then the chain rule says times the derivative of the inside, times 2x. Well, there it is. So what's the correct answer? Let's try another one that doesn't work out quite as nicely. I'm not going to have the 2x dx that's exactly here. Now, to do integration by substitution, I have to have this x to the 1st power someplace. But it can vary by a constant. So the 2 didn't have to be there, but I had to get the x, or I'd have to use a different method. So let's try another problem. Not quite as nice, but to show what's going on. All right, let's see. And let's do this. I wrote it down. It's x cubed. Let's see. The integral of x cubed times e to the x to the 4th dx. And I want to integrate that. And it looks crazy. It looks like, oh, this is something I can't do. I will tell you, typically when you have x's multiplied by something else with x's, it's either going to be substitution, if you can find a substitution that works, or it's going to be integration by parts. So this one does work, because think of the inside function. If I was doing the derivative, I'd say, oh, the derivative of this piece, e to the x to the 4th, is e to the x to the 4th times the derivative of x to the 4th. Well, that x to the 4th is the u substitution. That's my inside function. So again, I go let u equal x to the 4th. And when I take the derivative, du is 4x to the 3rd dx. And I have the x to the 3rd dx, but I don't have that 4. So a nice little trick, just multiply this by 1/4 on each side. And now these will cancel out. Oh, the x to the 3rd dx, there's my x to the 3rd dx. That becomes 1/4 du. That becomes this. So that x to the 3rd dx, 1/4 du. So that x to the 3rd is gone. I just have e to the x to the 4th, which is just e to the u. Well, that's easy. The antiderivative of e to the u is just e to the u. So I get 1/4 e to the u plus c and I resubstitute. Let's write these a little darker so you can see them. So I get 1/4 e to the x to the 4th plus c, and I'm done. Again, check by taking the derivative. How would I take the derivative? Let's see. Well, the derivative of this is going to be 1/4 constant multiple, e to the x to the 4th. I keep the exponential, but the chain rule says times the derivative of that exponent, 4x cubed, and the plus c, of course, goes to 0. Well, this 1/4 cancels out that 4, and I get x cubed e to the x to the 4th. Correct. Ta-da. And so that's what I do. Do make sure to check these to make sure you're right. Also, remember, if you have an indefinite integral, put on your plus c, because it's the family of all functions. We don't know what the constant is that this was the derivative of. So we have to plug in that plus c, unless, of course, we have limits of integration, indefinite integral. All right, hopefully that helped. Practice these. These are a little weird, but the key is looking for that inside function, the thing that you would have to do the chain rule on if you were taking the derivative. All right, so again, if you like my video, please like it. Click to subscribe to my video. We'll make more of these. And let me know in the comments if there's any videos you want to see that you don't see. And we'll get those going for you. All right, best of luck to you.